In this video we're going to take a brief look at recursion by comparing a for loop implementation of factorial with a recursive implementation of factorial. So if I can remind you, factorial is with an exclamation point, and it looks something like this. So 2 factorial equals 2 times 1. Let's do times 1. 3 factorial equals 3 times 2 times 1. 4 factorial equals 4 times 3 times 2 times 1. Right? And so for each of these we could actually say this equals 1, this equals 1, this is 2. Here's 6, here's 24, and 5 factorial equals 120. Now there is a procedure in the math library that you can do to run factorial, but that's not the point here. What we want to look at is different ways that you can implement this. All right, so if we were to do a for loop, let's say for I in range, let's say 5. So we're going to go, actually let's say 6, so that means we're going to be going 0, 1, 2, 3, 4, 5, 6. So really we should do this 1 through 6. So this is 1 through 5. All right, 1 to 5, and let's have another variable called j. Let's just start it off. Let's call it x. X if I is greater than 0. So if I is still positive, then basically what we're going to do is we're going to say x equals x times I. We're just going to multiply it. Otherwise, if it's not positive, we're just going to say, basically that means in this case that I is 0 or 1, and if you see up at the top, if you have a 0 or a 1, it just equals 1. So we're going to say x times 1. So we're just going to multiply by 1. Alright, and then at the end let's print the value of x. So if we're going from 1 to 5, we would expect the value to be 120. So we hit run, it prints 120. Right? So 5 times 4 times 3 times 2 times 1. Now let me show you a different way. This is a recursive way. So what we're going to do is we're going to define it using a function in order to do recursion. So we define, let's say factorial, let's call it factorial. Let's put in the number n as an input. And let's say if n is positive, then we're going to say n equals n times factorial of n minus 1. So we're going to actually call the factorial again, but decrease the number. So this sort of nests inside itself. So if we put in the value of 5 here, it would actually keep nesting 5, 4, 3, 2, 1. And then we need some end condition, which is in this case going to be when n is not greater than 0. So this is our end condition, else n just equals 1. Alright, so this is sort of our stopping condition. And we could write this differently. We could say less than or equals to 0, then n equals 1. Otherwise, n equals n times the factorial of n minus 1, and keep going down. It's going to be the same thing. And then we're going to, at the end, because it's a function, return n. Now that we've defined our function here, we can do factorial 5 and print that out. When we run it, we get 120. So you see, each time it goes through, it calls another version of itself. So basically we've got factorial 5 calling factorial 4, calling factorial 3, which calls factorial 2, which calls factorial 1, which calls factorial 0. And here, this returns a 1 and sends it back up, and this gets its own value and says 1 times 1. And then this gets the value of 1 from earlier and multiplies by itself, and then this gets the value of 2 below and multiplies by itself, and then this gets the value from below, which is 6, and multiplies by itself. This gets the value of the one below and multiplies by itself and returns finally 120. Right, so this is factorial, and it kind of nests, and this is using a recursive technique rather than a loop. Oftentimes this produces a more elegant solution, and typically takes a lot less code. And sometimes there are things that you can't do with a for loop, or where recursion actually makes a lot more sense in terms of how things are structured. One thing to look out though for is that with this stack, if this stack of functions gets too large, sometimes the program will fail because it runs out of memory. In that case, you may want to look at breaking it down into other smaller functions, or using a for loop and offloading the memory somewhere else. But that's a more advanced topic.